Good afternoon, sir.
Yes, good afternoon as well, sir.
Yes, sir. We will start within 5 minutes, sir.
Yeah, okay. Thank you so much.
Sir, let me start the session, sir. Good afternoon, sir. Let me start the session, sir.
Okay, sir, we could.
Yes, sir. Good afternoon to one and all gathered here. I like welcome all the participants for the day 6 session to offer AICT sponsored 6-day short-term training program on emerging trends and research challenges in the next generation wireless network. Welcome you all. It's my pleasure to welcome our today's resource person, Dr. Jonathan M. Cancino, Quality Assurance Head, EEE Section, University of Technology, Muscat, for this STTP. Welcome, you, sir.
Thank you, sir.
Education is not a filling of your bed, but the lighting of your fire. I'd like to give a short intro about our resource person, Dr. Jonathan M. Cancino. He completed his Bachelor of Science in Electronics and Communication Engineering in University of Saint La Salle, Bacolod, Philippines in 1998. He completed his Master of Technology from Technological University of the Philippines, Manila, Philippines in 2005. He completed his Doctor of Philosophy in Technology from Technological University of Philippines in 2012. He having a 5 years of experiences in the industries and 20 plus years of experiences in the teaching in various reputed institutions. He had passed a Microsoft Certified Professional Examinations and Microsoft Office Specialist in 2003. He is a Cisco Certified Network Associate and a Cisco Certified Network Professional, and he is one of a professional electronics engineer. He has various skills like computer repair troubleshooting, networking, and visual basic programming. He acted as a chairperson and delivered special lectures in various seminars, workshops, conferences, and training programs in various inter and international reputed institutions. Now, I'd like to hand over the sessions to Dr. Jonathan M. Cancino. Please, sir.
Good afternoon, sir. And thank you so much for that generous introduction. So, is my voice clear enough, sir, to be heard?
Yes, sir. It's okay, sir.
Then I will be sharing my screen so that we could start the presentation as well. Okay. Okay, so are you able to see my PPT presentation?
Yes, sir. Visible, sir.
Okay, so thank you so
Okay,
much.
sir.
I will just minimize this screen on my right side. Okay, so first of all, I would like to greet the uh, chief patron and patrons of this particular training conducted by the Congonado College of Engineering and Technology. I would like also to thank the organizer for allowing me to be part of this particular training. So the 6-day training to be conducted here online have a topic related to emerging trends and research challenges in the next generations of wireless network. So it is on the emerging trends as well as on the challenges in research, particularly in wireless network. So for the next 2 hours, you will be with me and hoping that at the end of this particular session, you will be able to at least open up your uh, mind in some opportunities that my presentation will be providing. So as mentioned in my PPT, the topic for today is related to the LoRaWAN, obviously from its devices towards its application. So first things first, I would like to have a copyright disclaimer that the videos, the pictures, the content which I borrowed from different authors are mainly used for teaching and research. All rights and credit will always go directly to its rightful owners, and there is no copyright infringement intended. Now, to start my presentation, allow me to ask each one of you, how familiar are you with the IoT? Are you considered as an expert? Are you just a beginner? Or someone that simply knows the word IoT? So according to a survey conducted by A.T. Kearney, 3% of the population never heard about IoT. So it is just a small number. 5% of our population are just beginners in this particular technology. One fourth or a quarter of the population were casually informed, maybe through a friend or through other platform. The good thing here is that there is almost half of the general population which have idea on what we call as Internet of Things. And another opportunity for all of us here this afternoon to explore this particular technology using the LoRa and the LoRaWAN network. I do hope and I do presume that participants this afternoon belongs to this particular category, an expert, okay, in IoT. So IoT can be deployed in so many ways, and my presentation is one of them, okay? So this is the current scenario in the IoT technology. So allow me again to remind you of how do we define the word IoT. People uses this word a lot. My question is, are you able to explain IoT correctly to people who are just simply starting to learn? Is your understanding about IoT enough? Or do you have alternatives on how you will be able to deploy projects or research related to IoT? So let's go first on its definition. So IoT is simply defined as network of physical objects. When we talk about physical object, that includes devices, vehicles, buildings, animals, and any other items which has an embedded electronics, software, and most especially sensors that allows us to gather and collect information from those use cases that we are trying to target. And another component of the IoT is its network connectivity. It cannot be an IoT without a network. So these softwares, electronics, objects, networks allows us and enables us to basically collect, exchange, and I would like to add another word here, analyze data. Maybe you have heard data analytics already, isn't it? You have heard data analytics. And this is one of the important thing now in IoT. Imagine how many billions of bytes are being wasted every day in the internet. Data that were not even processed. But because of data analytics, data collected from these sensors can be basically analyzed to provide us adequate information, particularly in our decision making. So this is the simplest way to define the word IoT. Now, you understand already what is an IoT. My next question would be, where is IoT? Are you having an experience with an IoT devices right now? Let's see, where can we find IoT? Basically, IoT is almost everywhere. Okay? From a simple wearables, from our smartwatches, to medical applications, more particularly now that we are in the pandemic. IoT plays an important role in tracking, determining, projecting those problems that we have now, particularly with COVID-19. What else? Majority of the applications of the IoT is also dedicated to home automation, wherein we are able to remotely control devices at home. IoT is being used extensively to lessen the burden of humans. I don't know if you will agree with me that as we progress to the 22nd century, people and humans tend to be lazy. Am I right? Am I lazy? Definitely. Because we rely so much on the technology. Every activity must always be associated with technology. One question, can you live a day without your mobile phone? Can you survive a day without your mobile phone with you? I doubt. Okay, sorry to say, but I really doubt. Why? Because majority, if not all of us, are dependent on the technology that basically improves the quality of life, but at the same times allows us to be more dependent. So IoT can be applied in POS, point of sales. It can be applied in a smart city, smart campus, autonomous vehicles, agriculture, and so on and so forth. Okay, it has limitless boundaries. So allow me first to show you how an IoT architecture works. Why do I need to have this premise? Because in dealing with LoRaWAN, you should have comparison, because some people think that LoRaWAN is a new technology. It's not. It's been there with us. The only problem is we are not able to utilize the technology. So allow me first to show you the main components of an IoT architecture. What do we have here? We have the thing or the devices. These devices can be a GPS, it can be a sensor, temperature, humidity, location, okay? It can be an RFID or it can be any other smart devices that allows us to collect information. And on the other hand, information collected from this device must be forwarded to a gateway. This is where LoRa and LoRaWAN will come in. Okay? So at least you already have an idea where this particular training is going. So these devices in an IoT architecture can have LoRa devices on it. And on the other hand, the information sent to a gateway could have a LoRaWAN gateway as well. So informations from those two components are basically forwarded to the server for storage and for analysis. It is very important for me, if you will ask, that the information we gathered from those things that we place must be analyzed later on for future decisions or for improvement and upgrading of our project. Now, all of this would always require an interface. An interface can be your desktop, a laptop, a mobile phone, and so on and so forth, so that you are able to remotely monitor all the activities in an IoT project. So the focus of my lecture or training today will deal more on the layer 1 and to the layer 2 of your OSI model. So it is more on the devices and more on the network. Okay. So what are the challenges that we have currently in the deployment of IoT? Okay. These particular challenges were provided to us by AICTE-Kearney. AICTE-Kearney is a firm that gathers information, okay, that allows us to analyze the current situation, particularly in the deployment of IoT projects. So what are the challenges? Take note, if you are a lecturer, a researcher, or maybe a person in the industry, we all face challenges, isn't it? So these challenges right now are more particularly on the infrastructures and platform. That shows us that there is a challenges being met particularly on the connectivity as well as on the sensing, which has lack of scaling needed to achieve acceptable cost of points. Hoping today that I will be opening your mind, particularly on considering LoRa and LoRaWAN devices as part of your deployment. Okay, so we identified the problem: complex interoperability, meaning mismatch among devices, legacy environment, exponential growth of data volumes, right? Can you imagine the amount of data being sent and stored in the internet every day? So these are the things that we will be discussing this afternoon. So allow me to introduce LoRa and the LoRaWAN. Again, LoRa and LoRaWAN are two different entities because I have met several people and ask them regarding their knowledge or regarding their familiarity on this particular technology. And a lot of them basically assumes or thinks that LoRa and LoRaWAN are one or the same, but definitely they're not. So first, Let me ask you another question. What is a LoRa? Have you heard LoRa? Have you used LoRa before? Have you any deployment of LoRa in your researches? Just a brief, just a brief discussion here. I've been invited to some of the colleges and universities in India, from Tamil Nadu to Hyderabad and some other cities in India. Sometimes as resource speaker like this, sometimes as part of panel. And also I have evaluated numbers of researches in IoT that would normally use the conventional way of deployment. And what is that? Using the cellular network, the NB-IoT, the GSM module, the 3G, the LTE, the usual thing that we use. But seldom that I've heard a researcher maximizing the use of LoRa. So hoping today it will give you an idea. So what is a LoRa? LoRa means low powered radio. So since it's a radio frequency, basically it's a wireless technology. Another way of seeing LoRa is that it's not just a device which consumes low power, but it could also provide us with long range capability. Low powered, long range. So let's see how they define the word LoRa. LoRa is a wireless technology that offers long range, low power, and secure data transmission between machines to machines and IoT applications. Wow. So therefore, deployment of IoT projects are not only limited to GSM, to 3G, 4G, and even 5G networks, which is a bit expensive, okay? Particularly if you are deploying your project into a larger scale. Maybe some of you might think, no, cellular is good, it's stable. Yes, you're right, it is stable, but it is very expensive, particularly on projects that requires you more devices to be connected. Okay? But LoRa, later on, you will notice that it is a cheap alternative, meaning low cost. Okay? So LoRa, by the way, has been created by a French company since 2009 and currently owned by a company called Semtech, okay, which is also a member of the LoRa Alliance since 2012. So it's nothing new. It's almost 9 years, right? So LoRa is what? LoRa is a wireless modulation technology. LoRa is a physical layer. I would like you to take note of this, that LoRa devices are physical layer devices that allows us for long range communication. This is how a LoRa device looks like. This is a transceiver that allows us to transmit and receive information. This type of LoRa is basically equipped with a microcontroller. It has a built-in microcontroller on it. Okay? So LoRa is having low bandwidth. So when we talk about bandwidth, it is also associated with data rate, isn't it? Because data rate and bandwidth are directly proportional. Aside from having a low bandwidth, it also consumes less battery. Battery that could last even for years. I'm talking here 5, 10 years. A device which is a battery operated that could last for 5 years. Wow. Can you imagine project being deployed remotely? Projects which doesn't have the access on a cellular network? How will you be able to deploy a project like that without a cellular network? The answer, LoRa. Okay? Take note that cellular technology are maximizing on its license spectrum. But by the way, I would like to make this one clear. I am nothing against cellular network. They're good. My emphasis only today is for you to appreciate LoRa. Okay? So that to remove the doubt. Now, LoRa is operating on the ISM band which is used for medical, okay, for industry as well, which is considered as a license-free band. So there are three frequency band currently used. Used in Asia, used in America, and used in Europe. So if you are planning to use LoRa, check whether which frequency will work on your particular region. Because maybe you will be buying a LoRa device which will not work in India for a reason that they are not using the same frequency band in your country. So make sure of that. LoRa, by the way, is also regulated in terms of its power. Maximum for LoRa currently, this one is working on the 14 dBm power cycle as well as the bandwidth. So Europe would require a zero point 0.1 or 1% for sub-duty cycle limitation. And what is good about LoRa? Because it has a link budget of 151 to 156 dB of link budget. So how it become important? Why having a link budget of 156 so important? Okay, let me show you later on the importance of link budget. But first, let us try to see the trade-off between bandwidth and range and data rate versus range. So, if you will ask me, what network does LoRaWAN belongs? LoRaWAN belong to LP1. What is an LP1? An LP1 is a low power wide area network. And this type of network is designed for sending small data packages over long distance on devices that works and operates only on battery. So there are a number of competing technologies in this particular network. We have the NB-IoT, which is being offered by the cellular network, the SIGFAX and the LoRa, and among others. But the two competing technology in LP1 right now is the narrowband or the NB-IoT and the LoRa. So let us try first see the relationship and of bandwidth on its range. What do we have here? We have the RFID and the NFC, the near field communication. Definitely, it will always have a smaller bandwidth and a shorter range. Normally used for IDs, which is normally used for mobile phone payment and so on. Bluetooth, on the other hand, would offer us a better bandwidth than the LoRa. Yeah, it's true. But we all know that Bluetooth is a bit limited when it comes to range. It could go as far as 100, but normally Bluetooth as a personal area network would have a distance of 10-20 meters, isn't it? Zigbee, on the other hand, will work on a shorter range, but a better bandwidth. So most of you might think that I could deploy my project using a Wi-Fi. Of course, using the 802.11 protocol for both the 2.4 and the 5 GB gigahertz band. Definitely, you can transmit adequate or large amount of data. But the question is, how far your Wi-Fi can go? 100, 200 meters, 500 meters, and that's it. Or why not use the cellular networks, your GSM, your UMTS, your LTE, and the current 5G that we have? Yeah, you could. It gives you better range, wider bandwidth, but it comes with a price. Am I right? It is a bit expensive, isn't it? Here comes LoRa. It is a technology that only allows you a small bandwidth. Now, have you deployed any IoT project in the past? Have you conducted research using IoT? Does it require large amount of data? Does it require faster data rate? I would presume that majority of those projects that you have won't even require much of the bandwidth as well as with the data rate. Why? For example, you want to remotely monitor and control temperatures in your farm, or would like to turn on and turn off devices at home. Do you think doing that would require a wider bandwidth? It's not. Do you think you need a fastest data rate? No, it's not. Correct? So why spend too much on something which you can get only at a cheaper cost? That is basically my emphasis today. Allowing and giving you option that will not give you too much headache when it comes to resources. Researcher, lecturers, you know that. It's not easy to secure funding. It's not easy to have enough resources. Let's be honest. We have brilliant ideas in mind, of course, but are you able to deploy it? Maybe not. Why? Inadequate resources. So this might open your mind in considering LoRa. So let's talk about data rate. Since bandwidth is not much, therefore data rate will follow, right? A narrower bandwidth would definitely result to a lower data rate. But again, emphasis on the range, right? On the range that it could cover. Some LoRa users have claimed to be having 500, 700 kilometers. Take note, kilometers of coverage. That cannot be easily done using a cellular network. So those are the things that you might consider. So in terms of data rate, this particular type of wide area network will have the least, but it will also have the best in terms of range. So those are trade-off. Guys, we cannot have the best of everything, even in life. We have to remember that. We always need to trade off. All you need to do is to identify what you need, right? In order for you to know what to use as well. Now, I'm talking about link budget earlier. For LoRa, it is around 151 to 156 dB. Take note, cellular only offers around 130 dB. So by the number alone, it is very evident that LoRa has a better link budget. A better link budget definitely will always result to a better sensitivity and also will result to a longer range. Now, let me define first what is a link budget. A link budget is simply defined as accounting of all power gains and losses that a certain communication signal will experience from your transmitter towards your medium going to your receiver. Since we're talking LoRa, we're talking about free space, right? Because it is wirelessly done. In this particular example, notice that when we deploy LoRa, we are regulated to only have around 14 dBm as agreed, okay? Now, From your transmitter, you will have a power of 14 dBm. As it passes through some components, cables, loss will always be there, reducing the amount of power. As we all know that before transmission, we are re-amplifying the signal. Okay? Before we send it to the free space, we have to pre-amplify the signal. So through your antenna again, we have increased the signal up to this level. Not much that it will exceed more than the 14 dBm as prescribed. Now, this is your free space now. So free space path loss and fading will definitely attenuate your signal. So what is attenuation? We all know that attenuation is weakening of signal. Signal as they move from transmitter through a channel to the receiver would definitely weaken. Am I right? Now, there are so much challenges here in free space. There are so many obstacles that could face. Here, I am only assuming that there's none. Okay? So signal as they move would definitely suffer from attenuation. As they reach your receiver, notice that this signal will be amplified, but not back to its original power. It is way low still, right? Then suffer another loss and will have around 100 dBm negative. It's way beyond the 14 dBm from the transmitter. The good thing is that the sensitivity is good, right? The sensitivity on this particular example is good, that the signal can still be received. On the other hand, because it is still higher than the receiver sensitivity. By the way, sensitivity is a receiver parameter that allows us to receive and detect weak signal. Okay? So at this point, we are yet able to detect the signal. Now, a little bit of review from our bachelor degree, that we are taught that free space path loss is directly proportional to the square of your distance. Common sense would tell us as distance increases without the use of any repeaters or amplifier, signal would definitely decrease, isn't it? And on the other hand, when your frequency is on the higher side, it will also increase your free space path loss. Notice, as frequency increases, your wavelength decreases. So the higher the frequency, the easier for signal to be attenuated. In some higher frequency, a simple rain could definitely affect the quality of your signal. So in general, your free space path loss can be affected by distance as well as by the frequency of your signal. So here it shows that when you double the distance covered, you will be increasing your path loss by around 6 dB. And the difference in free space path loss between the 868 megahertz and the 2.4 will be around 9 dB. So it's a bit significant value. So let's talk about sensitivity. So sensitivity, as mentioned earlier, is the capacity or the ability of your receiver to detect minimum amount of signal. But take note, there are some parameters that may affect, okay, your signal at the receiver side. One is the thermal noise, right? The thermal noise generated at the receiver, as well as your noise figure, which is basically the measure of your input signal to noise ratio to your output signal noise ratio, as well as, of course, your signal to noise ratio. So from this equation, it is very evident that your bandwidth, your noise figure, as well as your signal to noise ratio has a direct impact to your sensitivity. So we have to make sure that you have enough sensitivity to detect signal, particularly for long-range transmission. Now, this is just an example on how to calculate the link budget of a LoRa. So transmitted power is rated at 14 dBm, a bandwidth of 125. By the way, for LoRa, you can go as high as 500 kilohertz bandwidth. You can go as high. Then we have an SNR of 20 dB using the spread factor of 12. We have a noise figure of 6 dB. Well, in fact, it has a slightly lower noise figure. So calculating your sensitivity, this gives us a value of 137 dBm or negative 137 dBm. It's a very small amount of value that makes your receiver to have a better sensitivity, because even at a lower value, they are still able to detect. Now, calculating your link budget, it will be just your transmitted power plus the sensitivity. So it will be resulting to a value equal to 151. So almost the same as the 156 projection that we have earlier. So using this link budget and propagating the signal in free space, assuming that there are no obstacles in between, your signal could go as far as 800 kilometers. Wow, it's very far. But this is ideal value, right? This is not an actual value. This is not real value. This is theoretical value. So, to be honest, in order for us to determine exactly, we need to consider problems encountered in free space. And what are those common problems that we have in free space? In free space, signals can be obstructed by certain objects such as buildings, trees, posts, and so on and so forth. Signal can be diffracted. Diffraction means that as the signal hit the corner of an object, it will bend down, recreating the direction of your signal. And on the other hand, if signals suffer reflection, this is what we call as multipath propagation. So when signal is being reflected, there are tendencies that the signal will reverse, particularly in terms of phase, and that the signal might encounter the common problem that we have in wireless communication. We call it the ISI, right? ISI is the inter-symbol interferences, right? So these are the real problem that we have in wireless communication. And due to this obstruction, diffraction, and reflection, our signal will be attenuated. And if signal is attenuated, it will definitely decrease your range. It will have an impact to the distance covered. Okay? So, what are the different modulation technique used in LoRa? Most of us, I presume that we are familiar with what we call as the chirp spread spectrum, or commonly known as the CSS. So CSS is a spread spectrum technique that uses wideband linear frequency modulated chirp pulses to encode information. To make this definition simpler, a chirp spread spectrum is basically, unlike FSK or ASK, this type of modulation does not require a carrier. Okay? It is a carrier-less type of modulation. And the good thing about chirp spread spectrum, because it cannot be easily detected. That is why it is most popular in military application. It even goes below the noise level, right? So if you are wanting to detect or interfere or capture this data, it is be a bit difficult. Unlike a narrow band signal that can be easily detected. So chirp spread spectrum is much popular here in LoRa, which allows us to demodulate below noise floor, creating a better sensitivity as compared to FSK, resulting to a better power density. It is a more robust to interference, meaning less susceptible, noise, and even jamming. It has a tolerant on frequency offset, unlike the direct sequence spread spectrum, and it could simultaneously occupy on a single channel if a different data rate. So what are the key properties of a LoRa modulation? So LoRa modulation will definitely offer several key benefits. Its robustness is very high. Okay, robustness means tough. It has a fading and multipath resistance. And the best thing is that it has a long range capability. Now, for a fixed output power and throughput, the link budget of LoRa normally exceeds than that of a conventional FSK. With this, you are able to enhance the range 4 times greater than a conventional FSK. FSK is the frequency shift keying, a digital modulation technique. Okay, so it could provide you with a 4 times enhancement, particularly in range. So by comparing the data rate, bandwidth, and spreading factor, you will notice that your data rate is affected by how we use the spreading factor, as well as bandwidth and sensitivity. On the first table on your left, notice that we have a different configuration. We are having spreading factor from 6 to 12, right? That would result to a chip per symbol of 64 down to 4096 with a LoRa demodulator signal to noise ratio of -5 down to minus dBm. When we calculate our link budget, by the way, we use the SF12 having a -20 dB of signal to noise ratio. Now, these are the available bandwidth for LoRa, the 125 and the 250. Now, I am comparing the extreme value of spread factor. Having a spreading factor of 6 on this particular bandwidth would result to a higher data rate. Wow. Using the same bandwidth but with different spreading factor would reduce the value of your data rate. Now, if I will ask you which one is better, using a spread factor of 6 or using a spread factor of 12? The answer would normally rely on your project. Your project cannot be the same for most of us. For example, you require a higher data rate. Then choose for the SF of 6. But take note, your sensitivity will only have a value of 122. Now, when the applications you require for a project would only require turning on and turning off of devices, you don't need much of it. 293 bits would be enough for you to be able to turn on and off those devices or even to capture or monitor a certain parameter. So having said, it will improve your sensitivity. Now, which one you will use? Again, it will always depend on your project that you are working on, right? There is no right or wrong here. My point is that you are always given the option. You are always given the choices, right? That is why you need to understand first your project in order to understand what parameter will be suited for your particular researches. Okay? So again, data rate, bandwidth, spreading factor, and your sensitivity have relationship among them. So we already know theoretically what is a LoRa, a physical layer device. Okay? Normally connected together with microcontroller, sensors, and battery. So what is a LoRa one? Take note, from the word LoRa, we added the word one. As we all know, one stands for wide area network. So LoRaWAN still is a low power, wide area networking protocol. Okay? Take note, LoRaWAN is a protocol. It is comparable to IP. LoRaWAN protocol is used for us to communicate to the internet through a LoRaWAN gateway. Again, LoRaWAN and LoRaWAN gateway is also two different things. When you mention the word LoRaWAN, you are referring it to the protocol, just like your IP. Okay? And LoRaWAN gateway would definitely be defined as a device used to gather information from your LoRa devices. So LoRaWAN is developed by LoRa Alliance, okay? That wirelessly connects battery operated devices where to the internet via regional, national, or even global networks. There are so many public and private networks and operators that can be used now or utilized in LoRaWAN. Okay? The target here is again applications in IoT. Okay? That normally requires bidirectional communication, end-to-end security, mobility, okay, for geolocation and tracking, and obviously localizations of services. Again, LoRaWAN is a protocol. Now, where does LoRaWAN belongs? Okay, so LoRaWAN belongs to an LP1 network. We initially compared LoRa and LoRaWAN in terms of range and data rate and bandwidth, isn't it? Now, we are comparing again LoRa technology with other technologies existing in terms of its battery life. Notice that again, LoRa turns out to be one of the best option for long range, low power application where battery life could last between a year up to 15 years. Take note, it is battery operated, right? No need of a renewable energy. No need for a solar energy. Why? Because it takes you more than a year to replace the battery. Now, where does your LP1 fit? Where can we use this particular technology? When we talk about LAN, obviously, LAN would always offer us short-range communication, such as your Bluetooth or even your Wi-Fi. So what is good about local area network? Because it has already a well-established standard, a standard provided by the 802.11. Okay? It can be used as well indoor. That is what I like about Wi-Fi and Bluetooth as well. Majority of its application is indoor. The only thing that local area could not provide is your battery life, as well as the cost. Okay? Cost and battery life is basically a no-no for local area network. So why not use the cellular network? It's the best option currently for majority of us. Yes, maybe because you have a good existing coverage. Would you agree with me that not all part of India have cellular networks? I have watched a film called White Tiger, okay, that shows a village that doesn't even have a cell tower, okay. That only means that not all small part of any country are still covered. There are still areas which doesn't have cellular networks, right? So this is where your LP or LoRa technology would help. Again, your cellular will have a better coverage. Fine. It is indeed have the best data rate. But again, battery life is a no-no. And the cost of its ownership is so much, and it has a closed ecosystem. Now let's go to what I am talking 1 hour ago. A low power wide area network which is capable of consuming less power, check, minimal cost, check, and sensor positioning. What will be the disadvantages when you use LoRa? High data rate. Again, let's go back to my question. What application in IoT have you deployed that requires higher data rate and wider bandwidth? Maybe you have, but only few of them, right? And currently, standards are on the process of developing. There is an existing, but they are making it more cohesive by sharing all informations in the LoRa Alliance. So you have options here. I am not saying that use this immediately. No. What I am saying that I am opening your mind for another options here. So how does a LoRaWAN architecture looks like? Isn't it familiar? Does it look the same as your IoT architecture, which I earlier discussed? Indeed, it has almost same components. In your IoT, you require the device or the thing. In LoRaWAN, we call it end nodes. End nodes are devices which could sense, devices which are able to send information, okay, and devices which are able to interact with other devices as well. In your LoRaWAN architecture, you still need gateways. Concentrators are gateways. This is where LoRa resides in your end nodes. And this is where your LoRaWAN devices resides, because LoRaWAN devices are called gateways. Gateways are where your data can be sent to the internet. So information gathered from end nodes can be basically stored in a cloud through database, okay, through database. So this database can be processed using, again, the analytics, isn't it, right? So all these things must be, okay, viewed on a certain applications. So most of the popular application servers are the MQTT servers, such as the Things Network as well, which I will be discussed later on, and so on and so forth. So come to think of it, this process have been with us already. The only thing that we will be integrating now is with the use of a LoRa and a LoRaWAN gateway. The rest will be the same. Now, what are the different classes of a LoRaWAN device? So there are classes. So there are class A, class B, and class C. So we will be evaluating this in terms of its battery life and its downlink network communication latency. Latency refers to delay. Okay? Delay is a result of a low data rate. Low data rate is a result of a narrower bandwidth. So what is a Class A LoRaWAN device? So a LoRaWAN Class A device is a battery-powered sensor. Again, Class A is a battery-powered sensors. It is the most energy efficient, must be supported by most devices. Downlink available only after transmitting. Okay? So you see the plus and the negative factors on each classes. It has the best energy efficiency in terms of battery life. It's the best. Now, Class B LoRaWAN devices are still battery operated, but it already integrated actuators. Actuators are devices which are capable of turning in, moving, and so on and so forth. So it is still energy efficient with latency controlled downlink. It has a slotted communication and synchronized majority with a beacon. Now, here comes your Class C. Class C still have better life as compared to other technology, but among classes, it has the lowest. In this particular class of LoRaWAN, it has mains which are powered by actuators. That means devices which can afford to listen continuously. That is why consumption of energy for Class C is too much, because the device is listening continuously. Unlike here, that after performing a certain task, it goes to sleep. Okay? When your device goes to sleep, definitely power consumption is less, resulting to a better battery life. Unlike Class C, wherein your device is continuously working and listening. That is why no latency for downlink communication is included. Now, can I show you some example of Class A, B, C devices? Of course. So here are some of the example of Class A, B, and C applications. So majority of the Class A LoRaWAN devices are used for applications such as smart bins. Okay? So smart bins is capable of reporting a status few times per day. Let's say per hour, per 2 hours, per 3 hours. Okay? It has no actuation required. It means that you are only sending information. It doesn't require any response at all, right? That is why after sending the data, it could sleep for a few more hours. So it will only consumes extremely low amount of energy. Last 2 years, I visited Silvam College. There is a project related to this. Okay, smart bins. I like the idea, but again, maximizing on the GSM module. Okay, maximizing on the GSM module, and it's a bit expensive. Can you imagine how many bins you can install in a city? How many GSM modules and how many times you have to pay the network, right? If only they know that there's an available technology called LoRa, it might reduce the cost. Okay? How about Class B irrigation? For Class B irrigation, it allows us to send and report moisture a few times per day. But in Class B, there will be an added actuators. Why? Because in this case, if moisture is too low, you are capable of turning on and off valves that allows you to provide water to your plants. Thereby, on this particular case, you will be requiring more energy as compared to Class A, right? So latency will be again high, then very low, energy, which depends on your latency. And last example here is smart city. You will be surprised because I will discuss one of the use case in India wherein they have maximized this one using LoRaWAN, by the way. It will be on the latter part of my presentation. Class C maintains and indexes into a few times per day, but it constantly listens for network ping. As a result, this would require more energy consumption. So now, with this idea in mind, having your project as well, you can now at least decide on which classes of LoRa you will be using. Should I go with a class A, B, or C? Again, it will be determined by the type of project that you are currently working. So what are the different features does LoRaWAN provide? Okay. So some of the features is LoRaWAN provides us long range that could even be greater than a cellular network. LoRaWAN has indoor coverage. By the way, LoRa can be deployed indoor as well. It maximizes on the star topology, but not limited. Okay? In terms of battery life, since it is a low power, you can optimize the use. Battery lasting for more than 5 years, that would be great. And therefore, have better life than, again, I'm so sorry, okay, by stating again and again that the cellular system is far more less than the LoRa. Again, it will require or allows us to have a multi-usage. That means high capacity, multi-tenant, and the use of a public network. And the good thing here about LoRa is this part. It is low cost. Minimal infrastructure will be needed. Low cost end nodes will be required. And obviously, it requires an open source software. So what is the importance of LoRa? So let me give you some illustrations. I will try to draw. Pardon my drawing. I'm not an illustrator, but I will try my best. So let's see you are working on a certain project. Let's see you want to monitor your farm. Okay. So this is your farm here. And this is your house. Okay. So let's say you want to monitor the humidity, or might be the temperature, or might be your moisture here. Now, let's say the distance from your house to your farm is only around, let's say, 20 meters. Okay? Which particular network will be suited for this application? Which network? Most of you will think, yes, Wi-Fi will be enough. Indeed, you're right. You can only use Wi-Fi. You will be able to monitor this value. By the way, through the use of sensors, okay? You need sensors in order for you to collect data. Now, what if the distance increases from 20 meters down to 500 meters? Will be Wi-Fi still enough? Yes, there are Wi-Fi that can be used outdoor that could reach a distance like this. Yes, there are. So let's say distance now becomes around 2 kilometers, wherein Wi-Fi can still be an option, or majority of you, we can use GSM, obviously, the logical answer. We can use Wi-Fi, maybe, okay? Or we can use the 3G network, the 4G network, and so on and so forth. Yes, indeed, you can. But let me show you that these capabilities of network can also be provided by LoRa. And why you need LoRa? Because LoRa allows you to have better range, to have better battery handling, especially when it comes to power consumption. So in LoRa, you will have longer distances and less power consumption. That is why I would like you to at least try maximizing its capability rather than doing the same thing again and again, right? Every time we do IoT, the first thing that comes to my mind, GSM module, Wi-Fi module, the ESP8266, right? Or the 3G and the 4G and so on and so forth. So now we can shift. So allow me again to show you another illustration where LoRa can be of important. So let me erase my picture here and show you some more illustration. Okay, let's say same thing. Your house is here and you want again to monitor your farm. Now this is a larger farm which would require much of your sensor. So you can strategically place some sensors here on the corner, okay? And these sensors are basically connected to microcontrollers, right? Arduino, by the way, can be used. Python can be used. Raspberry Pi can be used. And obviously, you need a power source, which is just a battery. This is what I like the most. You need only a battery. Then, this will be connected to your LoRa device that will allows us to transmit data collected from the farm. Okay? So information could basically can be acquired and sent to your house for what? For monitoring and possible actions if in case you want to add actuators. Okay? So in this particular case, this type of projects, we have tried this in our BTech projects, okay? And one thing that we have observed during the time is that the battery that we use even lasted for 1 year. This is tested. We have tried this 2-3 years ago. A battery lasting for 3 years, wow. Enough. It's good enough really for us. So using LoRa here and another LoRa device here at home allows us to wirelessly be connected and collect all information from your farm to your home. So remotely, you can basically monitor your farm. Let's say your farm is located remotely and there is no way for you to be connected using a cellular network. What would be your best option? This one, isn't it? We are now having an ongoing project with an oil and gas company. Can you imagine? Their company is 50 kilometers located away from the main road. The only communication medium that they have is satellite at this moment. So they want to monitor their stuff. They want to send or gather information from other devices. So we are now trying to incorporate this technology, LoRa, because maximizing the satellite will be much expensive for them. So working with this company really helps us as well explore the capabilities of LoRa. So I do hope that this particular illustrations allows you to consider the use of this particular technology. So what are some examples of LoRa modules? There are several vendors really You can even search the Amazon. You can see a lot of products there. This one is from Reacts, okay? This one is from Microchip, and this is from AI Thinker. So all of these are good type of LoRa. I normally use this one, okay, or even this one. What I like about this, because it has a microcontroller on it, it can be interfaced directly to an Arduino as well. So these things are very cheap. I guess this one is what? Between $6 to $20, I guess. It's a bit cheap, really. You can purchase it in Amazon if you want. So now, LoRa can be connected on a point-to-point basis, just like what I have earlier. LoRa connected from home to your farm. You can do that. Or LoRa can also broadcast the same information gathered to multiple LoRa devices. Broadcast in a sense because a single data can be received simultaneously on a different locations, on a different LoRa devices. So your configuration basically could be a point-to-point or a multi-point or a broadcast type of configuration. Now, what makes LoRa 1 different, okay, from LoRa alone? Again, LoRa is a physical layer device that collects information from your sensors. What makes LoRa 1 different? A LoRa 1 device becomes a LoRa 1 gateway if, number one, it will be connected to the internet. So most of you might ask, is it necessary for us to connect LoRa devices to the internet? In my previous example, it doesn't require that the data must be connected to the internet. Am I right? Because it's a point-to-point communication wherein the information gathered from your farm is sent directly to your home. But if you want to view, control, monitor your end nodes remotely or even outside the country, therefore, this LoRa device must have a LoRa 1 gateway. Okay? Because LoRa 1 gateways allows us to be connected to the internet. So let me show you a simple illustration on how important a LoRa 1 gateway. So this is a basic example. These are LoRa 1 network. When I said LoRa 1 network, these are just collections of LoRa devices, okay? Which are individually connected to your end nodes, to any sensors that you wish to use. Now, all the informations here from your LoRa network must be sent to the gateway. So this information will be processed by your LoRa chip. So this is how a DIY LoRa chip looks like. Okay? So this is an AI thinker, a type of chip that processes all the LoRa information from a LoRa network. So in order for you to be connected to the internet, you need an internet chip. In this example, I use a Wi-Fi module, which is the ASP8266, that allows me to connect to the internet. So again, a LoRa chip and an internet chip integrated to a single board, excuse me, to provide internet gateway so that information from our LoRa network can be stored and processed to our servers. Okay? So those are the simple things that we are able to do. So your servers here, the most common servers right now that most people would use is the TTN or the Things network. The MQTT as well can be used, and so on and so forth. So this is the basic configuration of how your project will work. Also ThingSpeak, by the way. I have used this one also, ThingSpeak. is another good type of server that you can use. I use this when I try to monitor water metering and energy metering. It's a good interface, might have a limited amount of storage, but enough for project purposes really. For researches, ThinkSpeak TTN will provide you a good form of server. So gateway again refers to this device. Okay? Now, gateways can be classified in two types. In terms of position and in terms of channel. So when we talk about gateway types in terms of position, what I mean are indoors and outdoor types of gateway. And when I talk about channel, I talk about a single channel type of gateway that allows only one connection or a multi-channel type of gateway. So this is how an indoor gateway look like. This is a Dragino brand, okay, which is capable also of having a single and multi-channel. So it looks like a router at home, right? Notice that your gateway can also connect directly to a one network as well, or even to a local area network. There are options if you buy this type of gateway. And again, this type of indoor gateway could handle a single or multi-channel. So how does an outdoor LoRaWAN gateway looks like? So this is an example of a LoRaWAN gateway which is used outdoor. So those are some of the classifications of LoRaWAN gateways. Now, let me introduce to you the LoRa Alliance. So LoRa Alliance is the fastest growing technology alliance. It's a non-profit association which has more than 500 member companies right now, committed to enable large-scale deployment of any LP1 projects, IoT projects, development, and its promotion. So there are more than 500 member companies right now. If you notice here, another new members have joined, such as the Amazon, Intel, I guess, also have joined, and some other important brands or countries have already joined the LoRa Alliance. Would you like to know the current situation of LoRa technology in India? This is how it looks. From 2016 to October of 2019, these are only few of companies which have joined the LoRa Alliance. Only a few companies. Popular company here are the Tech Mahindra, we have the Tata Communication, the Senra, right? And take note, institution. When I talk about institution, that means the academe. Can you imagine only a few of them? That is why it is a bit of challenge for us LoRa user to inform people to please at least take a look and try this technology. Okay? So since 2019, these are only few numbers of members in India. So currently, there are 157 companies and the growth is growing. Now, based on my research, as of April 2020, this is during the pandemic, do you know that the coverage of LoRaWAN in India is less than 20% only? So some of you might think, oh, come on, this is bad for us. We only uses 20% of the LoRa. You know what? This is not bad news at all. I consider this as good news. I took this as an opportunity for Indian people to maximize its opportunities. Less than 20, it's fine. There are countries that even doesn't use LoRa. So for you to have at least 20% is better than the other country, isn't it? And this gives you more opportunity to maximize its features. Now, what are the opportunities that we have right now? Currently, we have how many participants? Maybe around 20 to 30 participants. Not all of you have the same capabilities, isn't it? Not all of you have the same specialization. So allow me to give you what are the opportunities in LoRaWAN for non-LoRaWAN players. If you think you are a system integrator, then you could basically explore on these different areas. If you think you have skill on device manufacturing, then go ahead, make something or create something that would customize devices to a specific design, or go to data analytics. Take note, information collected from these devices needs to be analyzed. And with that, you can basically explore on this particular area. And not, and last but not the least, you can basically also explore on the service provider side, wherein you can offer various model of sensors and connectivity as a service, or offer some business to business or business to consumer solution. So these are the opportunities which is India is awaiting currently. Take note, only 17% are considered expert and 50% knows about IoT. So this is providing us more data and information to explore. Again, if you are now working in any institution or in academe, make this thing as part of your passive income. You can create projects for these companies really while doing your job as an educator. Like me, I am an educator, but I am doing project as well with other companies. I call it collaborating. Why we need to collaborate as researcher? Because we don't have enough resources, isn't it? There are so many companies who are interested with your ideas. All you need to do is to be confident enough to explore these things. That is why collaboration between you and other big companies could happen really in the near future. That will solve your problem when it comes to resources. So again, take note, it's not a problem, but rather an opportunity. So if you notice here, can you imagine that only roughly 1% of the deployment of LoRaWAN in India is 1% coming from institution? My God, this is a bit low. Why? Because majority of us, particularly those who are in the education sector, we tend to use the conventional way of deploying our project by maximizing on the cellular network, isn't it? Right? So given this data, you can basically explore and collaborate with public operators, which roughly having contributed around 93% of its deployment. So this makes you having more opportunity to explore on the LoRaWAN network, right? And only a few, around 6%, were done privately in this particular cases. Now, let me show you some areas wherein you can maximize as well. Of those LoRaWAN networks, 98% of them are used outdoor. Wow. And they are public. So therefore, you can basically tap on them and maximize its usage, right? So given these ideas, by the way, these informations are taken from India. I'm not talking about US, Europe, or any parts of the world. This is particularly targeting the current status of LoRaWAN utilization in India. So in 2019, remember, only a few companies, only a few companies are with the LoRa Alliance. But in 2020, see how LoRa Alliance and LoRaWAN ecosystem in India have grown. Institutions have increased, which really, I feel happy about these things because a lot of companies, institutions now are involved in the development of this particular technology, right? So it will be an opportunity. For some of you who are not yet using the LoRaWAN ecosystem, you might be surprised that there are some companies you wish to work with are basically a member of this alliance. Okay? Now, let's go to some comparison here. Based on the study, LoRaWAN application would definitely compete with the NB-IoT. NB-IoT, let me remind you, is a cellular system technology. And take note, the only technology that could compete with it is the LoRaWAN, right? So it's a good sign. It's a good indicator. And notice the increase. It is exponential, meaning the adaptation is very good. There is even a projection here that this year your LP1 network might surpass your NB-IoT network, which is a good sign. Okay? So where can we use LoRaWAN technology? There are so much use cases here. You can use it in water and gas metering, public security, street lighting, monitoring, waste management, agriculture. It's limitless, right? So allow me to share some of the use cases in India. Okay, smart lighting. So this particular project, okay, were deployed in three major cities in India. This is actual information. Okay, this project were deployed in three major cities in India, wherein they use 150 LED lights, okay? Because this is a street light. So what are the key features of this particular project? They were able to remotely monitor street lights that includes turning on and off or even dimming of the lights. They were able to determine the number of dead lamps that requires maintenance. They were able to identify theft. Can you imagine? Street light being stolen by some individuals. It happens, right? So these things allows your government to save 15% of energy. Wow. 15% saving on energy is a very good achievement already. Much of the income, much of the expenses were saved by just simply employing and deploying this type of project. Can you imagine 28% of the lights which were stolen are currently saved? Again, these two factors always translate to savings. Savings in terms of money, right? So as a result, CAPEX means capital expenditure. CAPEX cost would definitely decrease because of these things. What have we done? We only monitor, okay, lights by putting some sensors indicating that they were removed or not. So when they are removed, they might be stolen. So given those ideas, simple ideas by the way, we are able to reduce the number of street light being stolen. And at the same time, since we are capable of monitoring the status of this street light, we are able as well to save ample amount of energy, so, which is good, right? So given this simple idea, by deploying it on a LoRaWAN network, these three cities are currently enjoying the benefits of it. So this is only one use cases in India. Another one, employee health and safety. Can you imagine every year there is around 2.78 million work-related fatalities in India. Imagine that in 2.78, those are your families, wife, husband, daughter, sons, right? Can you imagine those fatalities? And this can be reduced by simply monitoring your employees by putting some sensors associated with the health and safety. As a result, since we're able to monitor and track, we are able to save too much money in relation to work-related injuries, right? If someone gets injured, what will happen? We will use the insurance. Insurance would cost us a lot. Can you imagine your country is spending around $90 billion for a work-related injury and illnesses? I am not saying that we will eliminate this problem. No, we will reduce this number significantly by just simply deploying this project with the use of a smart option and cheaper option, which is your LoRa network. So again, in terms of safety, it also reduces to an extension of 50%. Wow. It's a very high reduction in the incident of work-related injuries just simply because of this project. So another example here is the smart metering. Again, this project has been done in India, wherein utilities such as water, gas, and electricity can now be easily monitored, okay, in a cloud-based platform. Readings will be more accurate, faster meter reading without human intervention, meaning if you are the company, less human resources will be needed, resulting to a less number of expenses, right? Improved manpower utilization, low operating costs resulting to a less labor. And what is good is that data will be analyzed based on its consumption. You know what? 2 months ago, I paid around 50,000 Indian rupees for a 1 month water consumption. Why? Because we found out that there is a leakage on my water system. So can you imagine paying 50,000 Indian rupees for a month of consumption? If only that company have this particular network in place, they might have already determined that I am already surpassing the regular amount of water consumption every month. Given that information, they might already inform me that there is any problem in my pipe system. So given those ideas, a lot of money can be saved, isn't it, right? So this particular case or use case that I have presented this morning are only a few, okay? Because I have limited amount of time to be with you this afternoon. So I hope that you have gained knowledge on this particular topic, as well as open up your mind and provide you with opportunities to explore on this particular technology. So once again, thank you very much to all the participants, organizers, and patrons of this particular training. And may God bless us all. Thank you.
அடுத்து
Dear participants, if you have any doubts or queries, you can ask now. Sir, thank you, sir. I think there is no queries from participants side, sir.
You're welcome, sir.
Yes, sir. Let me close the session, sir.
Yes, sir.
Kind words are short and easy to speak, but their echoes are truly endless. Likewise, our today's resource person give you more knowledge to ours. So in this way, I like to thank our today's resource person, Dr. Jonathan M. Cancino, Quality Assurance Head, Triple Section, University of Technology, Muscat, for providing this wonderful session. Thank you so much, sir.
You're welcome, sir.
Yes, sir. Dear participants, kindly hold on. Regarding this HTTP, we have a test. We will send the information within some more minutes. Sir, thank you, sir. You can leave, sir. Dear participants, this is the time for a live feedback. So participants are requested to provide a live feedback about this HTTP. Participants, you can unmute yourself and uh, please provide a feedback. The feedbacks are welcome.
This is Dr. Champion from Jaya Institute of Technology, Jaya Group of Institutions. I think so. I would like to thank to Kongunad Engineering. I would like to thank you to HOD, principal, and all other staffs in our Kongunad Engineering College, sir. Thank you and thanks a lot.
Thank you, sir.
Thank
Thank
you,
you very
sir.
much, sir.
Any other participants wish to give up live feedback means kindly give.
Hello.
Yes, sir. Yes, sir. It's audible,
Hello.
sir. It's audible, sir. Vinod Kumar, sir. It's audible.
Hello.
Sir, it's audible, sir. Vinod Kumar, sir.
Yes, sir. Can you hear me?
Yes, sir. It's audible.
Sir, the 6 days HTTP, this is Vinod Kumar, Assistant Professor of Meenakshi Sundarajan Engineering College. So this is very nice sessions, all given the greatest effort from your Kongonadu team. This is a very well effort you have taken. So we are regarding the HTTP, we are expecting more from your side, sir. Thank you.
Thank you, sir. Thank you very much, sir.
Sir, good afternoon, sir.
Yes, sir. It's audible, sir.
Sir, I am Kannan, Associate Professor from RUS College of Engineering and Technology, Coimbatore.
Yes, sir.
I would like thank you for organizing the Kongunadu team. This is useful for our STTP first 60 sections. Thank you, one and all, sir.
So thank you, sir. Thank you very much, sir. Participants, recorded videos and PPTs, you will share your mail ID, registered mail ID.
Dear participants,
Dear participants, any other willing to give a live feedback means kindly give, or else we will move to a vote of thanks. Now I like to call upon Dr. T. Ura Jose, Associate Professor of EC Department, to propose the vote of thanks in this occasion.
of Kungnadu College of Engineering and Technology. First of all, we thank AICTE for sponsoring this online STTP on emerging trends and research challenges in next generation wireless networks. We also thank our management, principal, HOD, faculty members, and students for their support. Last but supporting the STTP for successful completion. We thank everyone.
Thank you, sir.
Dear participants, we are going to post two Google Form links in the chat box. So one will be the session feedback. So every session you are usually you are giving that session feedback, and another link will have the overall feedback and test quiz questions are there. 2 minutes time. So you have to. So each question carries 5 marks. You have to get 60 marks. Okay. So certificate will be sent to your given mail ID. Registration form you given that mail ID we will send within 2 days. Within Monday we will send all the parts. And also session video links also we will send within 2 days. So eligibility. So two Google Form links will be posted in the chat box. One will be the session feedback, another one will be the overall feedback and online test. Okay, so kindly we request the participants to fill session feedback. Second one will be the overall STTP feedback and test. So dear participants, session feedback and overall STTP feedback and the quiz link is posted in the chat box. We request all the participants to fill both links.
Sir, the link is not accepting, sir. It is telling that it is not open.
Link is not working.
Day 2 இருக்கு. So எல்லாமே day 2 இருக்கு பாஸ்கர். சீக்கிரம் ஒரு நிமிஷம் இருங்க செக் பண்ணிட்டு போறோம். So dear participant, kindly wait 2 minutes. We will give the correct feedback link. Kindly wait. Dear link. Now the link is working. Kindly fill your feedback and session feedback and overall feedback and attend the test. Dear participants, so kindly fill the feedback link.
Dear participants, kindly ignore the before form. Kindly fill the two forms. The one is a day 6 session to attendance and feedback form, and another one is a overall HTTP and a push link. Kindly check it. Dear participants, the Google form link is posted in chat box. You have to fill the two form. The one is a day 6 session to attendance and feedback form, and another one is a overall HTTP feedback and a push. So you have to fill both the forms. Thank you all. Dear participants, there are two forms given in the chat box. The one is a day 6 session to attendance and feedback form, and another one is a overall STTP feedback and a quiz link. Kindly fill both the forms. The quiz and overall feedback is mingled in a single form. So there is a two form. The one is a day 6 session to attendance and feedback form, and another one is a overall STTP feedback and a quiz form. Kindly fill both the forms. Thank you all. Dear participants, there is a two forms we will given in the chat box. The one is a day 6 session to attendance and feedback form, and another one is a overall HTTP feedback and a MCQ link. Kindly fill both the forms. Thank you all. Dear participants, we have given a two link. The one is a day 6 session 2 attendance and feedback link, and another one is a overall STTP and quiz link. Kindly fill both the links. Thank you all.